Hi, I'm going to talk to you tonight about some of the concepts in Chapter 3 of the Prealgebra content. Statistics, we're going to talk about mode, mean, median, range, and outlier. Here's the definitions. We have a set of numbers. The mode is the number that occurs the most often. The mean is the average. The median is the middle number, when the numbers are placed in order from least to greatest. The range is the difference between the least and the greatest number. And an outlier is a number that's in the set that's much higher or lower than all the other numbers. So let's take a look at a very small set of numbers and see how these apply. So 5, 7, and 9. The average of 5, 7, and 9 would be 5 plus 7 is 12, and 9 more makes 21, and 21 divided by 3 is 7. So the mean equals 7. The number that occurs most often is the mode. They all occur one time, so there's no mode. None. And the median number is the number in the middle, which is the second number. So the median would be 7, the same as the mean. And the range is 5 to 9, or 4. And there is not an outlier in this set. If I added a number and made it 142, then it would change all these other measures of center, but 142 would be the outlier. Let's take a look at a larger set of numbers. Suppose these would be the number of student absences at GMS in the month of August, September, October, etc. If I want to analyze these numbers, I should place them in order from least to greatest. And to save a little time, I went ahead and did that. 20 is our smallest number from August, then 87 from May, etc. on up. If we look at these sets of numbers, if we want to find the mode, and this set of numbers does have a mode, because 150 occurs twice, here and here, so 150 would be the mode. The median would be the middle number, and because there's 10 numbers, this one gets a little more complicated. We can count over 5, 1, 2, 3, 4, 5. And split right there. So there's 5 to the left and 5 to the right. And there's no number right in the middle, so what are we going to do? We're going to take the average of 110 and 99. So we add them up and get 2 of 9. And we have to divide that by 2. And we would get 1 of 4.5. Or 4.5, it's either way. And the range would be 20 to 169. Should be 149. I forgot about the mean. The mean is the average, and when we add all these numbers up, we get 1,087, and you divide that by 10, that's pretty easy to do, just shift the decimal over 1. So the mean would be 108.7, which is approximately equal to 109. And I did create this set of numbers, so there's an outlier. You can probably guess what it is. So take your guess. I'm going to tell you in about 2 seconds. If you guessed 115, you'd be wrong. If you guessed 20, you'd be right. The outlier is 20 because it's way different than the other numbers. And now I want to do some displays with these numbers. And I'm trying to be pretty quick because I had 14 minutes of recording time left on this memory card. So just a heads up that we might not get through the whole thing. Trying to do the first half of the chapter. If we don't get through it, we'll do another session. So I want to do a stem plot, and my range is 20, goes in the 20s through the 160s. So I've got to start with 20s. So this stands for any number in the 20s, and 1 is 20. This is 2 10s and no 1, so that's a 20. There's no 30s, 40s, 50s, but I have to put these in here, 60s, even though they don't occur. 70s. In the 80s, I have an 87. The other 80s, and then in the 90s, I have a 90, a 97, and a 99. And we don't need commas to separate these numbers, because this is, I think it'll be single digits here. This is how many 10s and how many ones that go with it. So when I get to the hundreds, I've got to put 10, because it stands for the number of 10s. There are no things in the hundreds from 100 to 109, but there is a 110. So this is 11 10s and a 0 is 110. There's also 115. There's no 120s, there's no 130s, no 140s. There are 2 150s, so I've got to put that in there 2 times, 2 zeros. And then there's the 169. So that's a stem plot. If I had another set of data, I could do a double stem plot. If I had this set has no 60s, but maybe there's a 63 in the other set. So that's just a quick example of what a double stem plot would be. I can organize these into a box plot, and a box plot would be like a number line. And this has to go from the 20s to the 170s roughly. So I'm doing this really quick, just kind of sketching it out to try to save some time. But I might put 10 and go by 10s here. 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170. The first step in the box plot is to find the median of the whole set of numbers, and we already figured out that was 104.5. So I put a vertical line at approximately 104.5 above the number line. Then I have this set of numbers, and there's 1, 2, 3, 4, 5 in this set in the lower half, and I find the median of that set, which is 90. Put a vertical line there. Find the median of this set, which is 150. Vertical line there. Connect these, that makes my box. And then I go to the height of the numbers, it's 20. And there's a real big spread or gap there, which really shows how this is an outlier. That number 20, then 169. And it's not an outlier because it's just a short space. So this represents how many numbers are in the lower 1/4, they're called the lower quartile. In the second 1/4, the third 1/4, and the last quarter. These are called the interquartiles. These two right here. The two in the middle. That relates to 4, so we split it into 4 sections. The lower end of our second quartile is a 90. The upper end of our third quartile is a 150. And the difference between those two numbers is called the interquartile range. IQR for short. That would be equal to 60 because 150 minus 90 gives us 60. So we're going to move to, we're going to put these on a bar graph. I could do that. This is going to be pretty cluttered. I'm not going to try to do all of it. But I would have the numbers on this axis. And I could start, I could go 10, 20, 30, 40, 50. Probably didn't leave enough space here to get all the way up to, I'm sure I didn't, all the way up to 170. So what I'm going to do to make it really quick is just put on the one that I have time to do, which is going to be August. And I have space to do August. So the other year would be August, and August goes up to 20. And then I would do September next, and I have to leave a little space. That's one of the features of a bar graph, you leave space. September goes all the way up to 110. So it would be going way up here, and you're going to have to use your imagination because I didn't have room to put all the way up to 110. I'll make a little break here. And if this was 110, it would come up to this space, and you can fill it in. And you do the rest of the columns likewise, where you just fill in the bars representing the height of the number that corresponds to how many kids are absent in that month. I think what I'm going to do now is convert it to a double bar graph. And I'm going to change the statistic here and say there were 20 people absent in August, but 12 of them in August, we had 12 boys absent and 8 girls. So I can make a key where I say black is for boys, green be girls, and in August, we put these side by side. For boys, we want to go up to 12, so there's 12 boys that were absent. So we go up to approximately 12 here. And for girls, there were 8. So I'm going to go a little less than 10. Oops, there's green there. And that would break down the other months in the same way, but there would still be a little space here between September and August. So that's how I could create a double bar graph. If I wanted to do a histogram, this takes a little creativity to make a histogram out of this. I could say how many how many months did I have where I had between 0 and 30 people absent? And now there's my interval, it's 30s. So I've got to go 31 to 60 for the next, because one of the distinguishing characteristics of a histogram is that you have intervals or ranges of numbers. And those ranges have to be equal. So I'm going by 30s. So it's 30 to 60, and then 61 to 90. You kind of get the idea here. 91 to 120. 121 to 150. And I still have to get in one more here, would be 151. Whoops, 151 to 180. And I don't have any numbers higher than that, so they don't fit in here. And so this would be number of student absences. And I kind of glossed over this, but I'm going to try to pick it up here. This horizontal line has to have a label, and the vertical line also has to be labeled. And this would be perhaps the number of occurrences. So how many times did I have 0 to 30 absence? One time, just August. So this would be 1 time, 2 times, 3 times. I think my highest number here is going to be a 5, 4, 5. So one time I had 0 to 30. Put that in like that. I didn't have any times where I had 31 to 60. I had one time I believe when I had 61 to 90. I'll take time to do one more. Now that looks like a space, but it's only empty because there weren't any no data in that category. When I go 91 to 20, I had 5 of them, so it's going to go all the way up to 5. And here you can see how those columns come up against each other when you do a histogram. So that's a feature of a histogram. There are bar graphs, they're separate, and each category represents one number or one piece of data. In histogram, it's similar to a bar graph, but the columns are joined together, and there's a range of data down here. And this should also have a title. We could call it student absences. So you have to have a title. I'll put that there. And you have to label this axis and this axis. So let's see, how can we do a circle graph with this? Another type of display. We could just take the 10 pieces of data, the 10 numbers, and say what percent of the whole thing are those numbers. So we took February, and it would be a total of 169, and that's out of 1,087. So I can figure out that that would be roughly 0.155, and there's some more digits if you punch it on your calculator, it doesn't stop. That's 15.5%. But what I want to do to figure out what part of a circle would that occupy, because a circle has 360 degrees, this is going to be 15.5% of 360, which is also the same as 155 thousandths of 360. And of these multiply 360 degrees. And when you either do that pencil and paper or punch it on your calculator, you'll figure out that you've got about a 55.9 degree angle. So you round that off to 56 degrees because you're going to do this by hand, degrees. And we're not that accurate with the protractor. You're not going to do a 55.9 degree angle with your protractor. Maybe you can. Show me. I'd love to see that. I'm not going to demonstrate how to use a protractor. I'm going to assume you can do it. But you start by drawing that first ray, the angle in, then you measure the 55, 56 degrees, mark it off, and you label that, perhaps label it February. And then you would do the other 9 months in the same way. So that's a really quick review of the things that we've studied so far, about halfway through Chapter 3 in our study of statistics.